Hi, everyone. I appreciate you coming today. I'm Taylor Bird. I'm a Cloud Solutions Principal here at Nimbo. We're a full-featured IT consulting and managed services firm. We focus largely on enterprises who want to, embrace cloud computing, mainly public cloud. So we're here today to talk about data center migration to the cloud. Pretty broad topic. I know everyone in attendance, probably knows this isn't a topic we can cover in a little bit shy of an hour. We could probably do 30 webinars and not cover all the topics. So the approach I'm hoping to take today is we want to show a public case study of a enterprise that we recently migrated complete infrastructure up to Amazon Web Services, talk about some of the topics, challenges that we faced during that, and some of the practical solutions we had to those challenges that Amazon Web Services allowed us to offer. The point being to just sort of offer you guys, an idea of the solutions that are available on Amazon. So as you're going through your own questions and planning your own migrations, or thinking if this cloud is, a cloud migration is something you wish to embark on, just to show the ways that, Amazon Web Services is a great platform for this, and, sort of equip you with, some confidence and some knowledge of the features that are out there. So to get into it, the customer we're talking today is Hess Corporation. Hess is a leading independent energy company. They focus on exploration and production of oil and natural gas. For those guys on the East Coast, you're probably familiar with Hess from plethora of gas stations in the area. For us over the West Coast, they're Houston-based, oil and natural gas provider. And a link there at the bottom. Just this case study is public, so feel free to check it out afterwards for any of the details of the topics we've missed. So, sort of the case study, the business problem we were faced with is in early 2013, we were approached by Hess. They had made the decision to focus on becoming a pure oil and natural gas exploration and production company. So what that meant from their perspective is they desired to focus just on those aspects and to sort of exit their downstream businesses. Mainly focused around 3 units, which is their oil terminals, their retail division, which includes all the gas stations throughout the eastern half of the country and some of Midwest, in addition to their energy marketing, which is a sort of free trade, true energy trading platform, as well as a direct-to-customer, direct-to-business sales platform. So, and they opted to do this through making a decision on each of those units to divest it, to sell it, or to spin it off. So we at Nimbo were approached by Hess to tackle the energy marketing business unit. The option there was to divest the unit, to sell it to a number of companies who were in that industry and interested in acquiring that business unit and continue to operate it. As part of the divestiture focus, they didn't want to re-engineer much of anything, to sort of increase the value, to not spend months and years, extracting this business unit and prepping it for sale. The decision was made, no matter what we do from an IT perspective, we want to essentially pick up the infrastructure and move it somewhere so that we can hand it off to a prospective buyer. And part of the challenge here was when we were brought in, the buyer wasn't actually known. So part of the project, in addition to just moving the infrastructure, was to make the infrastructure that was created portable and appealing, so that it added value to the sale. It wasn't just something that they had to pick up as part of this purchase. It was really a compelling reason to purchase from Hess and to purchase this unit in the state it was in. So the environment we were approached with was about 250 production servers. There was also a dev UAT staging system, so our combined total is about 600 server instances throughout the organization, supporting over 400 employees and a multitude of locations, central headquarters in New Jersey, corporate headquarters in New York, in addition to a number of remote offices and satellite facilities. Software and operating landscape, mainly a Windows shop, but all versions of Windows. I mean, we had several Windows 2000 boxes, a lot of 2003, and the full gamut of everything else. Majority 2008 R2, we had some 2012 in there, but every version of Windows we could really get. Mainly a SQL shop, but again, multitude of versions there of large systems, heavy transaction systems based on 2005, all the way up to more modern applications and newer developed apps all the way into 2012. And we also had a series of Oracle clusters, mainly running 10 and 11G, nothing too old there, but a pretty significant Oracle footprint as well. Software landscape was anything you could think of as is typical of an enterprise of Hess's size. A lot of .NET, custom applications, a lot of vendor apps that were off the shelf in .NET, in addition to Java, Python, C++. Pretty much anything that'll run on Windows we found in this environment. Hess had a large Citrix farm they used for application delivery of most of these apps, of the ones that didn't present like a web UI. And as part of this process, they wanted to increase their usage of that Citrix farm. They wanted to try to solve some of the delivery, problems with the divestiture, some of the desktop issues and things of that nature, by increasing Citrix and using Citrix for even more of the apps that maybe weren't delivered there previously. They use F5's Big IP platform for application security, some of the web application firewall and security inspection. Large number of their systems were integrated with the energy marketing division and within it using Microsoft BizTalk. And all their application development, application lifecycle management was done through various versions of Visual Studio and a pretty significant TFS install. In addition to all the infrastructure systems that you'd expect in an enterprise of this size, large Active Directory, of pretty significant Exchange footprint, and a large SharePoint farm. So all of these were in scope. Entire infrastructure needed to be moved. And it wasn't just one particular thing. It was a variety of software and operating system, things like that. So early on, Cloud was not necessarily a front runner in this project. They had some goals they needed, but there was a team looking at Cloud. There's a team looking at doing a colo and moving that out. There's also a team looking at just rebuilding the infrastructure on their internal data centers, maybe in a separate Active Directory forest or separate infrastructure rack, or something you could actually physically ship to the buyer at the time. Some of the key things we looked at that really made Cloud start to stand out, speed of the timeline. The timeline was very aggressive. We had to get this done quickly. Hess wanted to complete the sale within 12 months. They did not want to have a long transitionary period. They didn't want to have a long development period. So when you're divesting the speed is sort of takes away from the value of selling the business. So very aggressive timeline. And a lot of the other, the colo and the on-premise solutions both came back from various teams at about 13 all the way to an 18-month timeline to completely extract, rebuild the infrastructure, move it out, and solidify production. So the Cloud was coming back a lot shorter. We'll talk about kind of where we landed, but a lot shorter than a year. So that was a key win. Portability was a big deal. The Hess Energy Marketing Division was not a separate unit. It wasn't something that Hess purchased. It wasn't like, the Chicago office is energy marketing. So when we sell it, we'll just give the buyer the Chicago office, the Chicago data center, and cut the lines. Energy marketing was fully integrated into all their offices and all their data centers. It wasn't even like server racks were dedicated. I mean, they were sharing the same VM host with all the other divisions within Hess. So there was a need to go in and we couldn't just pick up individual servers or VMs. We had to extract them, including the Active Directory and Exchange, from the larger Hess piece. So the ability to do that and make this entire thing very portable was critical. And then after that was done, the portability was essential to supporting the unknown buyer. We didn't know who the buyer would be. We didn't know what the buyer's requirements. The buyer may not want public cloud. The buyer may want the environment to scale down because they already have some of the systems, or they may want to instantly scale it up because they support a much larger customer base. So the ability to be portable and flexible was a big win. And again, none of the colo on-premise options really gave us that flexibility that we were looking for. And lastly was the legal complications. Any of you guys who have been through mergers and acquisitions, divestitures, know that a big part of the problem has nothing to do with the technology or even the HR aspects. It's the legal. There's all these phases during divestiture, where the seller owns everything, and then there's a period where the seller owns it, but the buyer is invited in. There's a period where they both own it, and then the buyer owns it, but the seller can hang out in there. And lastly, the point where the seller is completely in control and there's no access. And handling all those transitions and who owns and who manages and who can access and who's the administrator and who can control gets incredibly complicated. So again, the cloud gave us sort of this common ground approach, of which a term we use here at Nimbo is called cloud escrow. Let's take your infrastructure, we'll put it somewhere that's it's not the buyers, it's not the sellers, it's a common interest. We can put it there, we can design it, make it functional, and then figure out what to do with it after the fact. So when we lined all those up against the other options, the cloud just made the best sense. And then we got into, okay, we're going to go cloud computing. Which cloud are we going to use? And there's a number of cloud providers out there. Even to support an enterprise the size of Hess, there's a number of big players out there. What really dialed us into Amazon being the best choice for this for Hess was a number of factors, starting with the performance requirements. We had very specific application needs, which I think you'll see in a lot of the applications out there in your own data centers. We had a batch run process where, job 1 had to complete by 2 a.m. because job 2 would pick it up at 2:05, and it would have to be done by 3 because job 3 would come in, and so on and so forth. And if this whole series of dominoes didn't fall just right, by 8 a.m. in the morning, the whole team would come in, they couldn't do their job. So when we looked at cloud, you're going to try to do one-to-one with your hardware as best you can. But one thing Amazon really gives you is, if you want the infrastructure to get out of the way, it can do that. You can just create your VMs and just do what that you will. But if you need to dial it in, you really need to have greater hardware control over the IOPS, the hardware configuration, the storage configuration, the networking layer. Amazon Web Services gives you sort of an unparalleled layer of control that you're not going to find at a lot of the other public providers. In addition, we had some software requirements that made Amazon a great fit. Older versions of Windows. Windows 2003 was a big one, and 2000 was even there. These weren't supported on other cloud platforms. Same with Oracle. At the time we started this project, Oracle was only certified to run on Amazon Web Services, and Hess didn't really have an interest in being the guinea pig for Oracle in a different environment, so that sort of checked again. Hess had a number of virtual appliances, not just application servers, but NetScaler and F5 are big examples. These are virtual appliances that, they're virtual and they're servers, but they have to act as if they're the network device they're representing. So the ability to have multiple network cards, the ability to be cognizant of multiple subnets and that layout, again, something that we just couldn't find in any of the other providers. And so even with all this, the main reason we went with Amazon Web Services is there was a desire from Hess to design this in a way that wasn't necessarily cloud specific. Because when you go talk to this buyer who was eventually found, they may not understand cloud. They may not, be familiar with the concept. They may not be interested in being familiar with the concept. So we wanted to be able to design the infrastructure in a way that would work on-premise, colo, or cloud so that it could be discussed. And we found that Amazon definitely gave us the best ability to do that. So now that we've decided where to go, the next step that we had to go with, which is sort of common in a data center migration, is the approach. How are you going to get to the cloud? And there's a number of different options. I've outlined 3 of them here on the screen. The first is extend. This is where you just use networking concepts, VPN, direct connection, to extend your network out so that at the end of the configuration, the cloud is just another subnet. We find this great for development, test, UAT solutions, projects, pilots, POCs, anything of that nature. But in addition, this is a great way to introduce cloud to your team. As a cloud consulting firm, we go into a lot of organizations where there's not so much a pushback or concern with the cloud. It's just, for whatever reason, it's a mystifying concept. People are scared of it or just have no interest because it seems so different. It's sold with all these, pictures and diagrams, and it just doesn't make sense. So when you extend in this way, it just becomes just another subnet. Your developer wants a VM. Your IT team gives him the VM in the cloud. He just uses it and starts to realize, listen, there's all these great things I can do in the cloud, but if I just want to use cloud computing in this dynamic scale and this pay-as-you-go, it's really no different than what I do today on my virtualized data center. It's just giving me more capacity. So extend's a great approach, and extend's almost always where you're going to start, even if that's not where you want to end up. So the second option is to rebuild. Isolate everything, build it from scratch. Every decision, design, call, engineering is going to be exactly designed for the cloud you're going for. And this is, I'm a developer by trade, so this is actually the interesting one to me because this works well for greenfield, new applications, new business sites. If you're getting into a new industry, maybe you're creating a new mobile app, maybe you're doing something completely different with your business and you need a complete new infrastructure, rebuilding is a great option. This also works well as your business grows. Maybe you decide that you need a more robust DR plan. Maybe your DR plan has been, a 24-hour 24-hour RTO, and you basically just have a disk and some servers somewhere. If it goes down, you reboot them and you reload them and you're good. And now your business has grown and your customers can't really deal with a 24-hour downtime, so you need a true DR site. But you're a small business, you can't go buy a data center. Colo maybe doesn't make sense. The cloud and rebuilding this new site in the cloud is a great option. And the final one is lift and shift. Lift and shift is, where you essentially just migrate the existing workload. You minimize reconfiguration. You don't really want to change anything. You try to map the infrastructure, the hardware, one-to-one as much as possible. And this is great for, closing down data centers, consolidating data centers. Maybe you have a DR site at SunGard or a facility that you no longer need the facility, but you're paying the rent because it hosts your backup data center. Lift and shifting that into the cloud, it makes a lot of sense. It's a great solution for that. And it's also very convenient. It works very well for this cloud escrow concept for mergers and acquisitions and divestitures specifically, where you need to take this infrastructure and you're selling it, but you're not selling everything. So you can't just put it in your own data center. You want to get it out there for everyone to use. So lift and shift is a great option for that. Great option for not really changing your mindset and just using infrastructure in the cloud versus readjusting to cloud. And lift and shift is the option we went and used with Hess to, again, minimize the amount of changes we needed to do. So, again, speaking to this architecture piece, we've decided to lift and shift. And speaking back to 2 slides prior, we wanted to be able to design an infrastructure that would work wherever it went. So, we have this infrastructure diagram. I'm not going to dive too much into it. It's in the case study. But essentially, this has all the Amazon Web Services icons on here, but this is not a very Amazon-specific cloud architecture. You could do this in a colo. You could do this on-premise. And that was sort of the point, to allow the engineers to design their subnet structure how they wanted, to create DMZs where they wanted, to control NATing between subnets, internet access, full routing tables, control what transgresses the VPN of the direct connect versus what goes out to the public internet. Set up the net scalers the way you want, set up the F5 the way you want, put your databases where you want. If you have a 3-tier application, you can mirror that. And Amazon's virtual private cloud really gives you the ability to do this. You can design it exactly as you want. You don't have to look at what you want and then get a list of limited things you can do in the cloud and do it. Most everything you'd want to do in a modern virtualized data center, you can just go out and do in the Amazon cloud using VPC. And this was a great option for us. So we built this architecture out, and then we sort of mapped the Amazon services that would work, and we got to work migrating. So once you've got your architecture, you've got your approach, you know what you want to do, and you've built the VPC, the next step is to get connected. And like I mentioned before, you're almost always going to extend into the cloud, even if that's not the final approach. Maybe if you're rebuilding, you're not going to do that, but for lift and shift and extend and a lot of the sort of combined approaches, it's the best first step. So the easiest way to do this to get started is just to do a VPN. The Amazon VPC will offer a IPsec tunnel with all the modern encryption and security key sharing that you need. It's just a number of clicks, and it presents a redundant endpoint that you connect to your on-premise VPN hardware. To make it even easier for most supported things, Cisco, Juniper, Sophos, you can click a button, it'll actually give you configuration script, so you can just run that on your device if you're comfortable doing that and get connected. Just takes a few minutes. Largely, I advise customers it's about an hour. Definitely can be done in 10 minutes, just depending on change control and things like that. But it's a great way. You get it all set up, you control routing, you get your VPN hardware configured, and this just another subnet becomes a reality. It's just there. It's communicating with everything you need it to. Now, eventually, you get to the point, like we did at Hess, where the amount of data transgressing that VPN maybe is too much for the VPN, or just the inherent nature of the internet. Latency is not necessarily controlled. It can go down, things of that nature. You might want something a little more robust. And for this, what we use is a feature that Amazon offers called Direct Connect. Now, Direct Connect will give you a direct network link between your data center and Amazon Cloud. The way they do this is they partner with carriers, Level 3, TW Telecom, fiber providers of that nature. You call your fiber provider. They utilize an existing link or set up a link into your building that gets you into their cloud network. And then that gets you to sort of an edge endpoint in a number of large data centers, the Equinox facilities, the CoreSite facilities, where Amazon has also set up handoff points. And then Amazon will partner with the data center provider to get you a cross connect. So at the end of the day, you have a direct link of low latency, consistent bandwidth, direct link from your center to Amazon, not using the public internet. Then you can also leverage your relationship with your carrier to get SLA guarantees and things of that nature, make them redundant. And you can also automatically fail from that back to your VPN if you ever needed to. So you create this really great, high-speed, highly available, resilient connection that can really give you all the bandwidth you might need for this sort of migration and connection. So once you're connected, you know what you're doing. The next big piece in any data center migration is moving the servers. That's the bulk of what you're going to have. So a couple options to do that. The main two that that I talk about are cloning or rebuilding. These are exactly how they read. If you want to clone, you're essentially going to move a VM image directly from your on-premise virtualization stack into the cloud. Amazon supports VMware, Xen, and Hyper-V, just natively supports the image. If you're a vCenter customer and you don't, you can deal with, shutting the box down and moving it, there's actually a connector you can plug right into your console. You get an extra tab, you click a button, and it takes care of it. It just moves the machine into Amazon for you. There's also a product from a company called Hotlink that does similar for Hyper-V and System Centers type install. So you can do that. You move everything. Obviously, the problems inherent to the VM today will be inherent tomorrow because nothing about moving it to the cloud just fixes everything. But it's a great option if you are just lifting and shifting and totally don't want to change anything or rebuild. And then there's a rebuild option. You rebuild it from scratch. If you start with a clean state, you go in and you pick your base image, which a number of OSs are supported. You can also go in and find community images, which are like an OS plus some open source software. Or you can go to the Amazon Marketplace, where there's thousands of vendor-supplied solutions where it's a virtual machine with software custom installed, ready to go for a full turnkey solution. You just click a button and it comes up. Now for Hess, all the pros actually kind of lean towards the clone export option because we were trying to be fast. We didn't want to re-engineer. But we ended up doing the rebuild, and the option for that was a business call. The business didn't feel comfortable handing off an environment if they couldn't rebuild it from scratch. Maybe a server was built 5-6 years ago. You could hand it over, it works today, but if it failed a day after you transitioned, they weren't confident delivering that sort of solution. So we rebuild everything from scratch, of the transition. And I'm going to stop there just for a second. Quick note on cloud licensing. This is a topic that can be a webinar, a series of webinars all to itself. But just to touch on it briefly, all EC2 instances are built in an OS included model. This is sort of inherent to the service provider licensing agreement requirements of that. So there's no way to bring your own OS license to EC2. Number of OSs are supported. Of Windows, obviously, all the open source Linux ones are there. In addition to prepackaged solutions for license included for Red Hat Enterprise, SUSE Enterprise, Oracle Linux is there, often through its open source variant. But just know that you have to, all your EC2 instances have to be licensed at the OS level from Amazon. In terms of vendor software, it's a little bit different. You have a number of options. I've boiled them down to 3. Kind of going backwards on my list. You can do an ad hoc, bring your own license. A lot of smaller software vendors don't necessarily have a cloud policy. They're just going to license the software as if it were running on premise. So you call them and talk to them about that and get the license. Some do have a cloud policy, so it's the same thing. Microsoft is sort of all over the place on this one. Certain products like Exchange, it's complicated to license in this model. Of others like System Center, they have a full matrix of 1 data center license equals 4 cloud OSs, things like that. So a lot of different options to just relicense it, like it's a new product. The second is on demand. You can go to the Amazon Marketplace, you can find a vendor solution, and you just run it and you pay per hour. Now you're going to pay a premium here. It's typically list or maybe list plus a little bit extra for the convenience, but you're truly paying per hour. So if you want to try out a new vendor solution, F5, Citrix NetScale, or even SAP, you can run that for 3-4 hours and you're going to pay for 3-4 hours. You don't have to go secure a trial license. You don't have to go purchase some year minimal license. You use it for the 4 or 10 or 20 hours, and then you shut it down and you don't pay for it again. So it's a great option for those scenarios. And the last is bring your own license existing. A lot of larger vendors are starting to realize that enterprise isn't particularly interested in rebuying every single license they have. It doesn't make sense. So a lot of the licensing programs are now starting to support of a mobility model. Microsoft calls it license mobility. IBM refers to it as the bring your own software license. Oracle doesn't have a branding model, but 10G and all the 11G licenses support this concept of, you've got it on premise, you're moving it to the cloud, you can just transport that license up. So I stop here to note licensing kind of gets overlooked in a lot of cloud planning that I see. It's both a pro and a con. The con is if you overlook it and you just license everything on the monthly model, like you buy your SQL licenses, your Oracle license from the marketplace, you're paying a huge premium. It seems very convenient, and then at the end of the month, you're very surprised with a bill. So you got to control that. The pro here is it gives you an opportunity to really work with your licensing provider and figure out some options. In many cases, moving to the cloud, you can actually get your licensing to be less of a cost. It's a great opportunity to look at that and figure out what models they now support which you can sort of leverage to increase your ROI when you do a data center migration to the cloud. So just something to look at, something to not overlook when doing this. All right, so moving on. Additional VM considerations, VM sizing is important. Amazon offers the widest selection of VM sizes out there. In addition to general purpose type devices, there's also memory optimized, CPU optimized, network optimized. There's some special use cases like a GPU back instance. So if you have something like Citrix, which can actually benefit from directly talking to graphics hardware, you can utilize that in the setup. And the other great thing about the cloud and Amazon is you can also change this. The decision's not binding. So usually with no more than a reboot, you can increase the size or decrease the size of the machine. So you're not bound to having to reconstruct massive pieces of infrastructure. And then storage, I just mentioned here, we're all used to a SAN world. I know the backing infrastructure of Amazon is largely a SAN. That's not how you're going to interact with them. You're going to interact with something called the Elastic Block Store, or EBS. An EBS is more of a DAS model where you're directly attaching the hard drive to the box. So for large volumes and performance, you're going to have to be familiar with and start to use software RAID type approaches, of which aren't difficult. It's just sort of different than how we've been thinking about storage for a while. And lastly, there's this instant storage option. All EC2 instances are going to come up with a temp store, a volume that doesn't persist or reboot. And a lot of people write it off for that reason. They don't use it because, it can't persist, what use do I have? But in Hess, we saw some significant gains just moving the cloud by moving something like the temp volume or the scratch base to this instant storage, because these are high speed, they're SSD backed instances. So anything like that, we got some inherent gains just by doing that. A couple clicks and the machine ran twice as fast as it was running before because the software was able to leverage that. So I look at those instant storage options and think about interesting ways you can sort of incorporate that to what you're doing. All right. And then, sort of lastly on VMs, Amazon gives you, like I mentioned earlier, the ability to really tweak how things run. You can just pick your instance size, you can get going with it, and you can use it, and that's great. But you can also really tweak a bunch of different parameters to get you that performance that you need. The first one to talk about is IOPS. IOPS are really critical in the cloud. I used to do data center operations, and IOPS in my line of work wasn't particularly something we looked at. Our database guys did, but for applications, not so much. But moving to the cloud, you really have to start focusing on IOPS because you don't have the convenience of just purchasing more hardware than you need because you're going to pay for that. So tweaking that sort of stuff is how you're going to get it. In addition, at Hess, we had problems like we'd have a database that was backed by a SAN with this massive SSD cache in front, and we were asked to match performance in a cloud setup, and it's very challenging if you just use the out-of-box features. So by tweaking the IOPS in the EBS configuration, we were able to achieve that similar level of performance. So, our options there is a magnetic EBS variant. It works very similar to, a low-speed SATA drive. You're getting about 20 to 400 variable IOPS. The next option is the SSD option. This is pretty new. It guarantees a 3 IOPS per gigabyte ratio, and you can do a 3000 max IOPS burstable. And this is great for almost any application, and also, small to medium databases benefit from this. And this is just an included option. You don't have to go provision the IOPS here, and you get great performance. And then lastly, if you do need to provision that, you need to control your IOPS, and you need to get to an exact number. They offer something called provisioned IOPS, where you pay for that ratio. So they offer you a 30 IOPS per gigabyte ratio and a 4000 max sustained IOPS. And this is how a combination of this, the software RAID, and some of the other items we'll talk about in a second, is how we got the performance of some of those massive database systems and massive transactional systems to match what was on premise. Also in the VM, we can do dedicated instances where you can go out and get single tenant hardware. This isn't often needed. The noisy neighbor problem is pretty well contained in the Amazon cloud because you're guaranteed your memory and your CPU, but at times your application will benefit from that, and Amazon will give you that option. There's also placement groups. If you have a cluster or farm of servers that only talk to each other, and they're used to working as part of a single VM host or VM cluster, moving to the cloud can introduce issues because they're just going over the network. So the placement group is going to give you those boxes can actually be placed into a single low latency 10 Gbps network, which is handy. It sort of mirrors that environment that they were used to operating in that maybe you didn't develop around because you've always had that. And there's also EBS optimization of it's sort of a custom hypervisor configuration that can really maximize the I/O. So you combine that with the provisioned IOPS, and you can get exactly the performance you need. And lastly, Amazon offers you a ton of networking options as well. In addition to multiple network cards controlling all the network, constructs that we discussed, there's also some optimizations. One is cluster networking. If you have a scientific or a mathematical app that's using like MPI or any of the other parallel libraries, that's supported in Amazon. You can bring up multiple instances, slap them in a cluster, and those libraries will work just as they do on-prem. There's also something called enhanced networking, which, similar to the EBS optimization, is a advanced configuration stack that sort of slides in the hypervisor and really maximizes its performance for networking and reduces latency and jitter and gets you that performance that maybe your apps were used to seeing on premise. So those are just a few of the more detailed options you can really get to in Amazon that help you solve a lot of the problems that we get. Is we're not worried about going to the cloud, but we are concerned about performance and matching things of that sort. So Amazon gives you a wide selection of tools to use to help solve those issues. And lastly, on VM, something, this isn't a technical thing, but something you can use to sort of maximize your cost savings, is there's a number of purchasing options. The one that everyone's familiar with is the on-demand. You pay an hourly rate, you pay for what you use, no commitment. You turn on, you turn off, that's what you pay. And that's what everyone's used to. And it's great. It's very affordable, and you can control your costs that way. But if you're going to move a data center to the cloud, you know that a lot of your workload is going to be on all the time. I mean, your domain controllers, your Exchange, these boxes aren't going to go down at night because people leave the building, things like that. So Amazon offers you a few options there. The main one you want to leverage is called reserved instances. So with reserved instances, you pay an upfront fee on a commitment, either 1 or 3 years, and in exchange for a reduced monthly rate. And this used to be offered as a single tier. You paid a fee and you got a rate, and I believe it was like you had to be on. You basically paid for 60% uptime regardless. So if you're off more than that, you didn't benefit from it. Now Amazon has come out with a tiered model where in exchange for maybe a lower upfront fee, you get a higher hourly rate, but you're still saving on demand. And the light model is great for periodic workloads. You have a server that's only online 2 days a week, but it's always going to be on those 2 days a week for the foreseeable future. You can do a light reserve instance, and you'll still have a dramatic savings. The medium, like I said, is more of a 50-50, maybe 70-30. And then the heavy is for those workloads that are largely on all the time. Like I said, your AD, your Exchange, your SharePoint, boxes that don't just come up and come down with customer load or users. You do a heavy reserve, and you can get some dramatic cost savings. In the worst case Windows scenarios, you can get up to 33-35% cost savings off on demand. And some of the best case Linux scenarios of using open source Linux, with a heavy, you can get as much as 60-62% cost savings off the on demand model, over that 1 to 3 year period. So it's a great option to look to really control that cost. And lastly, something that doesn't get talked about a lot, there's a concept called spot instances. Amazon, it doesn't benefit them to have a bunch of hardware that's not being used, and they realize that. So what they've created is sort of an API and a system they call spot instances for utilizing those resources that for whatever reason just aren't being used right now. Customers don't need them. And the way this works is really interesting. Typically using an API, there is a portal, but it makes a lot more sense in an automation scenario. You basically choose the max hourly rate you want to pay for an instance and the number of instances you want. And as long as your max price exceeds the current spot price of the instance, which is set via algorithms, your instances are online. And when you no longer exceed that, they turn off. So again, you want to combine this with an automation monitoring package to maybe adjust that max price to some other threshold, or just set the max one you want, depending on your scenario. Interesting use cases here. Some of the ones we've seen, analytic or test workloads where they can be interrupted. Large scientific, not a data churning process, but large analytics clusters that can maybe go down for a while. Software test, we see this used a lot. You combine this with a script that basically keeps your test environment off, and when it goes down, the script just says, oh, okay, my price is exceeded. I don't have any developers using it, so I'll just leave it off, and then it'll bring it back up when the price makes sense. And also from applications who can benefit from the increased capacity, but maybe don't require it. You've got a batch that runs and it needs to run in 3 days, but if the data can become available 2 days earlier, that's awesome. So you set your max price and you let that happen, and then if that matches, you get that extra capacity. And if it doesn't, if it exceeds what you want to pay for it, then it still completes in the same amount of time because you left that one running on a normal on-demand or reserve. So these are the options you can use to really maximize your ROI in the cloud, which becomes really important in a data center where you're looking at ROI and cost. So moving just a little bit beyond servers, support for infrastructure and support devices is a big deal. Another key win for Amazon Web Services here is supporting these, they're technically servers, but they're virtual appliances. The Citrix NetScaler we used at Hess for load balancing and routing and application delivery. Fully supported, available in the marketplace. You go search for the NetScaler, you get a VPX, you click a button, and it's up and running. You can support the networking layout, the proxy layout, the DMZ that you had on your on-premise Citrix farm. Full support. Again, as mentioned, we use the F5 for local traffic management and application security. Full feature set. There's a virtual edition. You go search for F5 and you launch it. And for those of you familiar with the F5, F5, even at a virtual level, works as a software switch. In a lot of the public clouds, you won't see support for that. You can only attach one network card. You can't use it. In Amazon, you can give this thing 40 network cards. You can plug it into 10 subnets and make it aware of all that and let it do what it's supposed to do, which is manage traffic between them. So full feature set, click of a button. Client VPN, we use Sophos and Microsoft RRA to get clients in until we got the NetScaler remote stuff working. Again, Active Directory, fully supported, works very well. All your monitoring systems, support for the software cluster, the software failover clustering, all the SQL always on. All these technologies work seamlessly in Amazon. Again, sort of keeping with that mantra of designing what you want and then being able to apply it in the cloud versus designing for the cloud. And one of the last two things I want to talk about, high availability and DR. So in the cloud, it's very easy to achieve good disaster recovery and good high availability. But the flip side is it also becomes very important to do those. You're now dealing with the internet. Regardless of your trust for Amazon, you're now dealing with infrastructure that you don't directly control, and you need to account for anything that could happen there. So the main constructs that Amazon gives you for this are called regions and availability zones. So regions are geographically distinct. Think of them as, East Coast, West Coast data center. They don't have a lot of cross communication. You can't just move things, automatically around and expect them to talk. But this is great for DR scenarios, true natural disaster, war, crime, things of that nature. You can actually have a secondary site across the country that can come up, and you can share some data and images, and a lot of the application services can float around each one. And the second are availability zones. AZs are geographically distinct data centers within a region. So think multiple data centers maybe in the same downtown area. These communicate on high-speed backplanes, so they are like working in the same data center or the same communication rack. And the only difference is like a server will be in a different subnet, but it can communicate just as if it's sitting next to it. And this is where you get your high availability, because it's unlikely you're going to lose both of those AZs at once, given that they are geographically dispersed. So for Hess, some of the things we did for HA is we'd span all resources across two AZs. If we had multiple servers, we'd put one in one AZ and one in another. If we had a server that maybe could not be load balanced, it could not be scaled out that way, what you can do in Amazon is you can actually define a auto-scaling group for that server that only has one instance alive at a time but spans 3 availability zones. So if you lose one of the AZs, the platform will reboot it into another one. So it's not exactly high availability, but in a lot of those scenarios we find on-premise, when I ask, what's your remediation path? Oh, we get an alarm, and one of my IT guys goes and he reboots the server. So now at least you can automate that process for some of these older processes that can't support multiple systems. You can also do VM snapshots, just like you would do in VMware or Hyper-V. They can be automatically pressed out to S3, which is Amazon's, robust 3-node storage cluster. And then in the databases, we'd use a similar concept, supporting RPOs as short as 15 minutes. You can push those files out to S3, and you can set lifetime policies on them. So you can actually control how long they stay there. They can self-delete. They can self-archive into Amazon Glacier, which is sort of a lower-cost archival storage system. And all these things that you're managing today somewhat manually or through other software are natively supported. It's very easy to build a very robust HA and DR infrastructure using Amazon Cloud. All right, and last, automation expansion. You've built all this, and it's great, and it's infrastructure. One of the key wins for the cloud is that it can be automated. It is completely scriptable infrastructure. One of the items I like to cite with Hess is after we were done building production, we were asked to make a copy of UAT in dev. And normally that would take a couple weeks, a month to rebuild this entire thing in a second copy. We were able to use the API and usage of something they call CloudFormation, which allows you to define a software and hardware stack and rebuild it wherever you need to go. Between all that, we were able to build both these environments in under a week with one resource, no downtime. And it was great. And for a lot of scenarios, your test environment, scaling up for your UAT, scaling down for workloads, things like that, you can use these tools. And almost all aspects of Amazon are scriptable. Server builds are a common thing we get, either building the server from scratch, starting with an image, maybe starting with an image and bootstrapping into Puppet. You can also use concepts like fog to control Amazon from outside of Amazon through Puppet. Network changes, adding, removing NICs, moving things around, all scriptable. Oops moments, which you apply the wrong patch, the wrong software to a multitude of servers, and now you need to roll those out of production. You need to roll other ones live. You need to fix it and repair. All that scriptable. You write it once and you run it. And even big oops moments. The big thing I comment here is not once but twice during the Hess migration, I got a call from the buyer saying, listen, we decided we need to change the entire IP range for the infrastructure. We were wrong. It's a completely different CIDR range. And this is, you hang up the phone, you just kind of hold your head for a few minutes here, like, what are we going to do? But using the API and the SDK and all the scriptable features of Amazon, we were able to solve this pretty easily. We were able to move the entire infrastructure, change every box's IP address in under 8 hours with just a single reboot each system. So everyone shut down their machines and got off their servers when they left for work. And they came back the next morning, completely done, new IP range, everything patched up. Just not something you can typically do even in a virtual data center, and definitely not in a non-virtualized or non-scriptable infrastructure. So just a lot of opportunities to grow, especially once you get into the cloud and expand. Look at the SDKs, look at the integration points, and really start to understand, this infrastructure isn't just a server that you build it and forget it. You can actually continue to do whatever you need with it in an automated fashion. All right, so what were the results of this? At the end of the project, Hess completed the sale of the energy marketing division for $1.2 billion. We were able to extract the entire infrastructure in 6 months. That's from the first time we met to production running completely in the Amazon cloud. We were able to support almost a seamless transition. We transitioned from Hess to the buyer in under 60 days, avoiding a lot of contract costs, transitioning service agreements, all kinds of things that wanted to be avoided. And one of the Hess leads like to joke that we handled some of those security issues in no more than a 30-minute meeting. But all the access to the environment was controlled with Active Directory. All the access to Amazon was controlled with their identity account management feature set. And the root access was controlled with a MFA key fob. So meetings, we all came together, logged into Amazon with that key fob, disabled the AD accounts that were no longer relevant, activated the counterparts, deleted the IAM roles for the for the seller side, for the Hess side, reactivated them for the buyer side. And at the end of the meeting, the buyer left with that MFA fob. So all the security things were handled in that simple fashion because you can control all these aspects in a really simple platform feature. Moving a little bit beyond the Hess project, the new buyer had never intended to leave it into the cloud. They wanted to pull it out of this escrow environment within probably 6 months. But after assuming it, seeing what it could do, seeing how well it could optimize its cost, they're now a client of ours. We're working to further integrate what we did for them here and also bring a lot of their on-premise stuff into the cloud now, and have really made them big fans of the approach. And we've also been re-engaged by Hess to do other cloud projects. The success of this has really made them rethink their infrastructure projects internally, and we're involved in a lot of that. So, that kind of wraps up my presentation. I hope it's been helpful, at least to pique some interest or give you an example of a lot of practical things you can do in Amazon to solve the challenges you might have when migrating. We'll go Q&A here in just a second. Some of the next steps here, it's easy to get started in Amazon. You just go sign up. And you can sign up for free. Amazon offers what they call a free tier. It's not a trial. It's not limited to educational users or nonprofits. It's a true limited subset of offerings of everything Amazon Web Services has for 12 months. You can run like a micro VM for an entire month. You can have a database online for an entire month. I mean, you can really get your feet wet with any of the services completely free of charge for 12 months. So search for Amazon free tier, go sign up for that. It's a great way to get started. And then, lastly, you can also connect, once you're ready to do more, connect with a partner. Nimbo's an advanced consulting partner for Amazon. We're a member of the AWS Partner Network. There's a number of high-value, great partners out there. Reach out through the partner directory or reach out through your account manager, and find a partner who can solve those needs. and get these projects going and get you migrated or leverage the cloud in whatever way you need. And the last thing I don't have on here, there's a program called Amazon Test Drives. I'd highly recommend you go check those out. These are sort of a self-hosted environment, templated trial of software. So there's all kinds. Nimbo's posted a few on BizTalk and SQL. There's a lot of other partners. There's SAP, there's Oracle, and you basically sign up, you click a button, and the whole environment's built for you, and then you can just toy around with how things will work and function in the cloud without having to build that infrastructure yourself. So a number of great ways to kind of get started there.